Hi, welcome to the channel. So today we're going to continue working with Pandas. The idea for today is to focus a little bit more on learning how to use Pandas rather than just doing data analysis. The idea is to start with very common operations, reading data and just selecting some columns and rows. Then we'll be working on aggregations using groupby and transform. Then we'll continue working with reshaping data, how you can manage this kind of operation that is actually very common when you're cleaning up the data. And finally, we'll be doing some data visualization. We'll be using for loops to do box plots. And then we'll be doing some plots with Plotly Express. That's a library that allows you to do interactive plots. And you can also do small multiples. And the advantage of this is that you don't have to write for loops. You can just pass a few arguments and then you get a plot. So stick until the end to get to that point. But the first part is perhaps a little bit less fun, but it's generally very good practice to learn this. So let's get started. So here I have a few libraries that we'll be importing: Pandas, NumPy, Polars. This is just for benchmarking. And we'll be using Plotly Express for plotting, Matplotlib also. This option here is just to allow you to print all the columns in Pandas. So hit Shift Enter and we run this. And here I set up some code so we can do some benchmarks. And we don't really need to run this, but basically I'll just want to show you the results. So if you read the data from Excel, takes about 1.41 seconds. So this is what we have here. So pd.readExcel. I mean, 1.1 seconds is not much, but if you have a very large data set, then compared to the other options, it's a lot slower. So generally, having the data in Excel is not ideal. So you should have it in a CSV file at least, or I don't know, some other file format that's better, such as Parquet. So here I'm reading it as Excel and saving it as a Parquet file. And if I want to read it again, it will be a lot faster. So here I'm reading it from the Parquet format. So let's see how long this takes. Let's see if it's the same as the benchmark that I have. So I have for this 14.3 milliseconds. So, I mean, we went from, yes, more or less the same thing. So we went from 1.41, that is the read Excel, to 14 milliseconds. So that's a lot less. So you can also save this as a CSV. So this is mostly for benchmarking. So if you read the file from the CSV file with Pandas using pd.readCSV without any optimization, any options, just read the file. That takes 27.9 milliseconds. So the Spark version is already almost half that time. So that's more or less what you gain from saving it as Parquet. Another option you have now is if you have a really large data set in a CSV file, you can read it with Polars and then convert it to Pandas. I mean, you have to be careful with this because if the file is, very large, maybe your memory blows up. But this is another option that is interesting. And if you do this, it takes around 15.2 milliseconds. So almost the same thing as if you would have read it from Parquet file. This option, I mean, without you doing anything, right? Just reading it from a CSV, you use Polars that has practically the same syntax as Pandas, and then you just do dot to Pandas and you convert it. So this is another interesting option to read a CSV file. So for the purpose of the tutorial, I'll continue with the default version. But yeah, I just wanted to share some results here that I think are interesting. So basically here, really all you do is just select the function, read CSV, and then pass in the file path. Okay, so let's continue with the second section. So these are really the most basic operations that you can do with working with data, and that is selecting columns and filtering rows. So one way to do this in Pandas is passing a list to the data frame. So here I'm selecting 2 columns. So I pass in a list, and we just select those 2 columns. And another way, if you have a lot of variables, sometimes it's a lot cleaner to create a list first and then pass it to the data frame. And this is generally a good practice if you have a lot of variables. So another thing we can do is filter rows. So here I'm filtering the rows with the state that's equal to California. So let me show you how this works. So if you run this, you can see that you have a Boolean result, and basically what you're doing is passing the data frame a Boolean mask. That's how it's called. So basically it's a true and false list, and that's what you use to filter the data. So this is how filtering works with one condition. And the thing is, if you want to add another condition here, the syntax gets a little bit, verbose. It's not very nice. It's not very readable. So that's why if you want to add more conditions, you can use the df.query method. So the way this works is df.query, just to call it like that, and then you pass a string with the condition. So think of this as a where argument in SQL. So if you already know SQL, in the where statement, we put these kind of filters. So if you run this, you get the same result. So another thing you can do with the df.query, so let's say if you have more than one Boolean condition, you just pass in this object that refers to and. So the most important ones are, this is and this is or. So the pipe, right? And these are very popular in all languages. So one thing we can do here is pass two conditions, and if you want, you can pass in a variable. So here I'm defining a city, just calling it Los Angeles, and you can pass it with the add syntax. So this is a lot cleaner than if you would have done it with this syntax. But let me show you how it works. If you would want to do it like this, so let's say so gender equals male, right? And df.city equals Los Angeles. So, I mean, this is fine. You can do this, but you have to include all these brackets. And I mean, I think I find it a little bit less clear than this. But yeah, that's at least my personal opinion. If you can avoid to type in these brackets, the code is more readable. So one thing that I generally do when I start working with data is clean up the columns. So if you look at this, we have columns that have senior citizens, so they have a space in between there, and they have different case, right? You have a caps here, and that's nice if you're making a plot or you're presenting data. But in terms of working with the data, I rather have them without white spaces and in lowercase. So for example, like this. So this is generally a pre-processing that I do when I start working with data. It just makes things simpler, and it also allows you to use the dot syntax. So for example, now you can do df.zipcode, and before you would have to do something like this, right? So yeah, zipcode with a space and with caps here, caps here. So I mean, it's just one more thing you have to take care of. So this is just a lot simpler to me. So okay, so let's talk about the data a little bit. Let me show you here the head. So what is this data about? So we have a data set that's about churn. So churn means when you unsubscribe to a service. In this case, it's a telecommunications service. So we have this churn label, and that is what the target, right, of this problem. So you can do value counts, and that shows you the number of customers that churned, that unsubscribed, and the customers that remain subscribed. And then you have a lot of variables that can be thought of as features of these problems. So you have the state, the city, the zip code, the location, gender, and some information about the service, how much they use it. And then you have this variable that's called CLTV, and that is customer lifetime value. So what that means is the expected value that the customer will generate in his lifetime, so into the future. So you basically add up all the money that you think these customers will spend in the future, and yeah, you can compute that in multiple ways. You could use a machine learning model to compute it, but here we just have it, right? And I mean, the data doesn't really matter for what we're going to do, but I think it's important that you understand that churn is the target, right? It's what we ideally would want to predict, even though we're not doing machine learning now, but that would be interesting. And CLTV is another variable that it's very important, right? The customers that have a very high customer lifetime value are customers that you don't want to have them unsubscribe. You want to keep them. And if they have a very high value, you might spend a lot of money to keep them. So, okay, so let's continue with the groupby. So let's talk about this example. So what happens if I do df.groupby and I just pass in a variable? So we get this a little bit cryptic result. So we get a groupby generic blah, blah, blah object. So what happens is that the data internally gets splitted. So in this case of gender, we'll have two groups and it'll be easier to understand. So I can loop through this df.groupby object. So first I print the name here, and then I print the group. And the group, in the end, it's also a data frame, but where all the observations are of the female gender. So if we scroll through these results, we can see that we have female here. I print some dashed lines here to show that we start with a different group. We have male and the other data frame. So you can think of this groupby operation as splitting the data in groups according to the variable that we pass or the list of variables. So how can we use this? So the nice thing is that you don't have to do this for loop in Pandas. That's done internally. So what you can do is just call groupby on some variable and then select a variable and compute the mean for each of the values of the group. And that's what we're doing here. So here I'm basically computing the mean of the CLTV, the customer lifetime value, for each gender. So that's basically the groupby, right? I'm taking a mean for a group. So there are multiple ways to do this in Pandas. Maybe what makes this confusing is the large amount of ways that you can do it. So if you pass in a double bracket here, instead of printing it like this as a series, it will print it as a data frame. So, I mean, yeah, this is perhaps you want to continue working with the results. Maybe you keep more columns. So sometimes the data frame, it's a better way to represent it. So another way you can work with this is using parentheses. So this is a method that allows you to do one thing at a time in a way. So instead of having one complete line that does everything, that's a little bit cryptic. Here you can think of it line by line. So the first line, you start with the data frame. The second line, you group by gender. Third line, you select the CLTV column. And the last one, you compute the mean. So if you, maybe in this example, it's not that interesting, but if you do more complex operations, then it starts to be useful. So for example, in this one, I'm adding more functions to the .ag. So before we were just calling the .mean directly, but if I want to have more functions computed, we can use .ag, that it's a shortcut for aggregate. And so, yeah, and one more detail here, if you pass in a double bracket here, there we go, we get a multi-index on the top of the column. So if you don't know what multi-index is, don't worry about it for now, but you have to keep in mind that if you just want these aggregations, this is the way to do it. But way that I'll be showing a better way to approach this in just 5 minutes. So this is fine. So here we're doing the minimum, the mean, and the maximum of this CLTV variable for each element of the group, so female and male. And that's fine. We're starting to feel that we're analyzing data here. So one more thing you can do is add 2 variables in the groupby call. So here I have gender and churn, and I select the same variable and I compute these functions. So, and now we start to see that a little bit more complex result where we have 2 variables in the rows as index, and then we have these variables that we computed. And again, if you don't want this double index on the columns, you can just remove this double bracket. And finally, this is the way I think it's a little bit more intuitive to do this. So you can avoid passing in this variable here. And you can simply pass the variable that you want to work with and pass in the function that you want it to be applied. And then you pass in a column name. So here I'm doing the median of the CLTV variable. So I pass in the column CLTV and the function. And basically in the other ones, I just changed the function. So, and this, what this does, it's that when you get to write this code chunk of aggregate, you can start thinking a little bit which variables that you want to aggregate or what kind of calculation that you want to do. You don't have to bring in advance those variables. And generally, I think this is a more practical way of doing data analysis. And here we have another example, so that where we compute the median of the CLTV on one column and the median of the monthly charges on another column. And what I think is great on this example is that you can do calculations on 2 variables, so monthly charges and CLTV, but you don't have to care about bringing those columns, keeping them on a list, as we would be doing, we're doing here, right? That we were kind of keeping this variable. So we just pass in the column name and the function. Okay, so I think this is starting to get a little bit more interesting. So you can pass in 2 variables. So here I'm doing gender and churn, and you can compute variables, numeric variables. So, and you can see, I mean, the female churners compared to the no churners, how did the CLTV change? So, and you can see that in this case for females, there is a relatively large difference of 4200 to 4600. And I mean, yeah, we can see something similar for males also. So 4200 45, almost 4,600. But in general, it seems that people that churn have a lower CLTV, which for the company it's good. Okay, so one more thing that's important is the transform operation. So, and the transform is, think of doing a group by and joining back the results to the data frame. So you basically expand those results to the data frame. So these are the two averages for each gender. So the average of female, the average of male. So if I transform that back, it will replicate those values for each gender. So this is for male and this is for female. And the result in this case is the same size of the data frame. So maybe here you can see it better. So if you create a new column with the average CLTV, and you can compare how it looks with the gender and the value that we created. But in the end, it's the same thing as a group by, but you just keep the results of the same size of the data frame. Okay, and now we have a little bit more tricky section. So let's talk about data reshaping in Pandas. And I mean, we could talk about this for many hours, but I just want to give an example. So here we have the data already in a very clean format, right? But sometimes we get data in what's called wide format. And generally, this wide format is not very friendly for data analysis. So let me show you an example. So this will be a relatively small data set in wide format. So what you would want to do, if you have, let's say, in the columns years, for example, you would generally want to put that in a longer format where each column is a row. And let me show you an example of how we would do that. So first of all, here I'm using the df.pivot table. So I'm basically creating what you would know in Excel as a pivot table. So you're selecting which variable you are interested. So I'm selecting CLTV, the variable on the rows, so churn label, the variable on the columns, so gender. And then I define a function I will use to aggregate the data. So I could just change this function or whatever, right? So it's also possible to pass in multiple columns in the pivot table. So here I have another example where I'm passing payment method and gender as columns, and I keep the index in the rows. And we can start to think that, I mean, this is a kind of possible data set that you might encounter in Excel, for example. And in order to make plots or do data analysis, this is not a very friendly format. So how can you go from this format into something more manageable for data analysis? So here's one way. So we have these two variables here, payment method in the axis and gender. So what happens if I call this stack function? So if I pass in the 0 index, I get this payment method that goes to the rows. So it goes from here to the rows here. So now we have the churn label, the payment method, and the gender in the columns. If I would have selected the first index, so the opposite would have happened. So the number 1 index here is gender. So this is 0, this is 1. So basically we grab the gender and we put it in the rows. So that's what happens here. So have the gender here. And if you wanted to get rid of the columns here and put them as rows, you would have to call these 2 times. And basically this is one way of doing it. So I'm just passing reset index here, so we get a 1 level for everything. But let me show you what happens if you don't call it. So you get this kind of weird result. So So basically here we have the churn label, the payment method, the gender, and well, this is the average of the CLTV. You can change the column name, but we can start to see that this is a data set that's a lot easier to make a plot. Another way to get rid of all this is using melt. So melt, in this case, basically does the same. So it basically melts in a long format the data. It depends. I mean, to me, melt makes sense, but for some people, they just use stack for everything, and you could actually do that. You can always use stack, and it will work. Okay, so that's it for reshaping the data. So now we'll continue with some plotting examples. So the first plot that we have here is how can we make box plots in a for loop. So we define a list of numeric column names. So CLTV, monthly charges, tenure month. And what I'm doing here is, I define a figure, define the number of plots I will do per row. This is the number of rows we'll have that gets automatically computed. And here I'm looping through the columns from this list that I define, num columns. And what happens inside the loop is that I create a new axis, new subplot in each iteration, and I call the boxplot function. So and here I pass in the column and I pass in by churn label. And you can think of this by as a kind of group by-ish operation where you're making a box plot for each element of churn label. And this is just setting the title. So this is mainly, making it look a little bit nicer. You can try removing this and see what happens. But basically this is the result. And if you would have a lot more numeric variables, you would have 3 plots in each row. So let me show you what happens here. If I use this, it looks a little bit cleaner. So let's take a look at what is going on these plots. So basically we have the CLTV variable, and the box plots, they give us an idea of the center of distribution. So the lower end of the box is the 25th percentile. The higher end of the box is the 75th percentile, and the line in the middle is the median. So here we can compare the median and say, okay, for the churners, CLTV is lower. The monthly charges median for the churners, for the churn yes, is higher than the ones that didn't churn. And then we can see that the tenure months, that I think is some kind of age of the customer, the churners have been for less time as clients. So this already gives us some idea of the relation of these variables with the target. That's why I think it's a great plot to make if you're working with binary data. So then another interesting plot you can make is with Plotly Express. So I mean, you could make a scatter plot with these 2 variables, latitude and longitude, with Pandas. But the thing is that you can't very easily customize it. You can do it, but it's not very practical. So that's why I prefer to use Plotly Express. And what we're doing here is passing px.scatter, which is passing the data frame as an argument, define the x-axis variable, y-axis longitude, and we define a color. And it plots we can plot by a factor, right? By a label. And you can, let's say, remove this. So you keep the ones that churn. It's kind of more user-friendly than this static plot that's practically by default has overplotting. So here you can see if there's a pattern. Ideally, you would find an area where there are a lot of churners, but I don't think that's happening here because there are a lot of churners here, but there are more customers. So it's not that easy. But still, it's interesting to be able to play around with the data so easily. And one more thing you can do with Plotly Express is you can very easily create what are called small multiples. And let me show you what I mean. So I'm passing the same arguments here: X, latitude and longitude, color, journal label. Opacity, it controls how, we're hiding a little bit the color of each dot. So in order to avoid overplotting, so if I put 1 here, it's, we don't see a lot of the blue colors. So that's why it's good to play with this parameter. And the core of these small multiples is this facet call. So what you can do by passing this variable is you can create one scatter plot for each value of payment method. So you have one scatter plot for mail check, one scatter plot for electric check, and so on. And if I don't pass this facet call wrap2, we get all the plots in one line. So it's better to say, okay, let's do 2 plots in each line. And I mean, you can play around a little bit with the options. There are a lot of options, and the trick of Plotly Express is that it allows you to do complex plots such as this one without having to write for loop. And here we can see that maybe there's some results, some interesting results. Maybe this electronic check that has similar pattern to there are more churners where there are more customers, but with the other methods, it's not that clear. And maybe those are good features in a model. And that's it. That's it for today. So we covered how to read data with different methods, and we did this simple benchmark here. And then we did some filtering and selecting columns operations, group by and transform, some reshaping, and finally some data visualization. So I hope you enjoyed the video. Please subscribe and like the video.